Hello students, this is Professor Chilai, and in this video we're going to look at thermodynamics and energy flow. As always, you can follow along with our Chapter 5 workbook. By the end of this video, you should have learned the first law of thermodynamics, you should be able to describe state functions, and you should also be able to describe the meanings of the various signs associated with heat or work or changes in energy. Let's get to it. So, uh, what is the first law of thermodynamics? Before we can talk about all of this other stuff, let's think about the first law of thermodynamics. The first law of thermodynamics is related to the law of conservation of energy, where the first law of thermodynamics states that energy cannot be created or destroyed. So it cannot be created nor destroyed in an isolated system. So what that means is that if you have an isolated system, isolated means it's not interacting with anything, it's by itself, then energy cannot be created nor destroyed. However, in the universe, the whole universe is an isolated system, but most times pockets within that universe, any setup that you have is not going to be isolated. It's going to be able to exchange energy with its environment. And so the way a system exchanges energy with its environment, so energy may be transferred through heat and work. So if a system gains or loses energy, it will have lost or gained those energy through either heat or work, because that energy that it gained wasn't just miraculously sort of spontaneously created, or if it lost energy, it didn't just disappear, it went somewhere. And usually we'll be using heat or work or both to keep track of where that energy sort of moved. And so if you're looking at any system, the internal energy, and U will be used to represent the internal energy, and that's just a word, fancy word of way of saying sort of all of the energy that something contains. It's kinetic energy, it's potential energy, it's chemical energy. All of it we'll just call the internal energy of that system. Sometimes people might just call this E because, for energy. But the change in the internal energy of the system will be related to the heat, right? Q is heat, or the work. Remember, delta here means change. So if there's any change in the internal energy of some system, it will either come from heat or from work or from both. And because there's conservation of energy, if a system gained energy, it means the environment lost energy. That's why the delta U of the system is equal to negative the energy from the environment, right? So this is similar to what we learned for heat transfer, right? Q of the system is going to be negative Q of the environment. This is also true for energy transfers. If a system gains or loses energy, the environment must have lost or gained energy depending on which one it is. All right. So what this means for the different values of Q and W? Well, let's think about it. If Q is positive, right, meaning Q is greater than 0, it means that the system gains thermal energy. Q is transferred thermal energy, so if Q is positive, the system gains thermal energy. If Q is negative, it means the system loses thermal energy, right? It becomes colder. For work, and the language here is very important. If work is positive, it means work is done on the system. So if work is positive, it means the system gained energy through work, so something else did work on the system. So for example, let's say you were in an elevator and you went up, right? The elevator did work on you, and then when you're on the 10th floor, if you started from the first floor, you would have gained potential energy because the elevator did work on you. Similarly, or on the other hand, if work is negative, it means that the system lost energy from work. And so you can think of that as like you running up a hill. You did work energy, yes, so you would have lost energy by doing that work. So the system energy is done, work is done by the system. So these these words are important. If something does work on the system, the system itself would gain energy. But if the system itself does the energy, the system would lose energy, right? And so work would be negative. All right, make sure you keep those two separate or clear in your head. And finally, if the change in the system energy is positive, it means that the system gains energy or energy flows into the system. And if the delta U for the system is negative, it means that the energy flows out of the system or the system loses energy. Okay, make sure you keep this handy to sort of identify what the signs of the various quantities mean. And finally, I want to talk about state functions. So the energy, the internal energy of the system is what we call a state function. And what that means is just the value depends only on the state of the system and not how it got there. So this is important. Let's draw a picture of what I mean by that. Let's say you were climbing a mountain. So this is you're climbing a mountain. A state function just really depends on what state you were in. For example, if you're here on top of the mountain, that's all that matters. It doesn't matter whether you sort of started over here and just went straight up, or maybe you start over here and then sort of did cutbacks to get there. None of the path you took to get there does not matter. Let's just make this a little bit clearer. You start in the same position, but you did cutbacks. None of that matters as long as we know where you are right now. So that's an example of a state function. And so heat and work are not state functions in this regard, but the internal energy is. So heat and work depends on sort of the path you take, but state function just depends on where you are right now. And so the exact path you took to get there, it doesn't matter. And oftentimes when we're solving problems with state functions, we can make up any path that we want as long as it all works out. So we'll talk a little bit more about how state functions work when we get towards the end of this chapter for different sorts of problem solving. But just keep that in mind. A state function just depends on where you are right now. All right, so that'll bring us to the end of this video. In this video, we talked about the first law of thermodynamics, how the energy change of a system is going to be related to heat and work, and also that the internal energy of the system is a state function, and a state function just depends on where you are, not the path that you took. All right, in our next video, we're going to talk about work, because we haven't touched on work yet this chapter. We did mention how internal energy is heat and work. So we're going to talk about work a little bit, specifically pressure volume work. I'll see you in the next video. Bye.